Today we're doing minimum problem 1674, minimum moves to make array complementary given integer array nums of even length n and integer limit. In one move you can replace any integer from nums with another integer between 1 and limit inclusive. Okay, and array nums is complementary if for all indices sum of number from first half plus mirrored position around middle is the same. Minimum number of moves required to make it complementary. Okay. I mean, okay, what is limit? What is range of numbers? 10 to 5. Okay, so we try all numbers from 1 to can change 1 to limit, right? So lowest is 2 and maximum is 2 times limit, and for each number there we need to know how many operations will it take. So the ones that are same is okay, right? Ones that are more than limit away, no, that's tough because maybe binary search for the limit, because let's say to get the limit L it takes n operations. Well, if we lower the limit, maybe that's not true. Maybe that's not true. Yeah, it's probably not monotone, or like monotone up to some point and then going the other direction. That's tough. Right now, okay. Like, can we do limit, I don't know, 10, right? We can't really change that much, right? If something is away by limit, in reality it might take you 2 operations to do that. That's not right. What if we would make a range, like in 0 you can do just that sum. In one operation you can go from anywhere to numzi, from like 1 to numzi, or 1 to nums whatever, right? So probably you wanna do like, that's how much you can subtract, so maximum of those two. That's interesting. So okay, that's fair. So we would have a number line from like 0 to limit plus 2 times limit plus 1 and or plus 2, and now here is what we are gonna do. let's say we have like L is nums I, R is nums minus I minus 1, right? Then we do ops of, so let's say S is L plus R, and then ops as minus, we can subtract at most R minus, like max LR plus 1, so we plus 1 there, and then ops S minus equals 1, and then ops S plus 1 plus equals 1, and then ops, best we can increase in one op is like S plus limit minus min LR, and then plus 1, and then else would take, so otherwise op 2 is 2, that would take one more operation, right? Or like if 2 less than S minus max LR plus 1, then like ops 2 plus equals 1, and then ops S minus max LR plus 1, and then if S plus limit minus min LR two times limit, then ops like that, I suppose. Actually, we should do plus 1 here, and that should be it. So for nums, then ops if because if it's like 3 and 5, I can lower by max of them, right? So by 5, but less than that, so I can lower by 4, so that's max minus that, and we subtract that, so we have that. Then ops S minus max LR plus 1, ops S minus equals 1, ops S plus 1 plus equals 1, then ops S plus limit minus min LR plus 1, ops something like that. Maybe. This is absolutely unlikely to work, but okay. I mean, what could it take most? 2 operations, so like, I guess this is safe. What, that doesn't work at all, that's crazy. How is it 2 operations here? Because this is 4, right? So we can make it one operation, we can lower it by 2. Really? Their sum is 6. Subtract maximum, you get 2. Six, 2, 4, 4. Yeah, so because this should be -1. Or no, yeah, I'm doing it absolutely wrong. I'm quite stumped, honestly, because like this. this should be 2, right? And then afterwards this should subtract 1 from here, and then 1 there, and then 1 there, and then 1 there, and this might work. That's completely wrong. That's ridiculous. Ah, okay. Oh my days, this is ridiculous. It actually worked. That's crazy. Okay, and I am going to not sleep again after workout. Horrific. Anyways, title is... What is the title, bro? Space, oh well, I guess. Okay, so let's try possible sum of operations it would take for make all pairs equal to it approach. For a given pair L nums I R nums N minus I minus 1 with sum S it will take us one operation to get sums to get sum of ranges to L dots operations to achieve for the given pair. brackets ops where ops I of operations needed to make all pairs have some I. Only thing we need is to add the of operations corresponding to each range to all positions in the range. Instead of using lazy segment 3, we can use a trick which updates a certain range AB with plus C by adding in a certain range AB by C by adding C to ops A and subtracting C from ops B plus 1. Then we just keep the cumulative sum going through all to I to C dot limit the current cumulative sum is the number of operations for current sum I. We just take all of them okay, so it's like O n plus where n nums limit first create ranges O1 ranges for each of the ON pairs and update the ops array in O1 range, which is ON in total. Calculate cumulative if then we over all I such that to C dot limit and just recalculate the cumulative prefix sum and update the answer in all one where I, which is OL, since our ops array has a length of OL. Oh my days, what a dogshit problem. I already should have finished my dinner. Goodbye.